it's Evan from SciMastory. Welcome to part 2 of the basics of a vacuum chamber. If you haven't seen part 1 yet, the link is in my description. Go watch that video if you haven't already, then come back and watch this one so that you understand this one a little better. So as I said in my last video, I got this vacuum chamber from the first Action Lab subscription box. So keep watching for 2 more cool experiments I'll be doing today. Now there are 2 ways to make a lower pressure. One way is to suck air out of a container, just like traditional vacuum chambers like I have here, keeping the size of the container the same. But the second way of making a lower pressure, according to the ideal gas law equation, is that you can start with a very small size or volume with only a few air particles in it and increase the volume, and that will also make a lower pressure. So I know that second part might have sounded really confusing, but I'll explain it right now. So for example, the plunger on this syringe is all the way down. The space inside is at atmospheric pressure, and let's just say that there's 10 air particles. So the end of the syringe is plugged so no air could get in. And now we increase the amount of space, but we're not increasing the amount of air. So while I'm doing this, the density and the pressure are decreasing, and it's forcing all the air particles to fill in the space. So they're getting stretched apart from each other, and that's making a lower pressure. So as I promised you in the beginning of the video, I would be doing 2 more cool experiments with my vacuum chamber. So in part 1, the marshmallow expanded because of the air in it. Well, the balloon has even more air, so what do you think it would do? So start pumping the syringe. So right now it's at atmospheric pressure. Start decreasing the pressure. Oh look! Wow! Immediately it just starts growing like crazy. So right now we're at half an atmosphere. Look at that! That's like at twice the size now. Whoa. So, definitely expanded. Wow, look at that. It's like almost off the ground. That rubber just pulled right on the sides of the vacuum chamber. So, what did it do? It expanded just like the marshmallow. So now let's let the air back in, and it should shrink down just like the marshmallow did. Okay, ready? 3, 2, 1. Yep. So, why did that happen? Normally, when you inflate a balloon, you make a higher pressure inside the balloon while the air around it stays the same. But right now, we're making a low pressure outside the balloon while the air inside the balloon stays the same. Since the air around the balloon is at a lower pressure than inside the balloon, it's the same as saying the air inside the balloon is at a higher pressure than outside of it, making it inflate. Now, when you let the air back in, there is no longer that low pressure pulling on the balloon to make it inflate. So it shrinks back down to normal. So by now you should notice that anything with air expands in a vacuum chamber. So another thing that has air is shaving cream. So I put a little shaving cream in my vacuum chamber. And let's test that one too. So it should expand for the same reasons the balloon and the marshmallow did. So let's see. Let's see how much it expands. Whoa. that's expanding too. So now look how much it expanded. We are at a little under 0.3 atmospheres, and that expanded a lot. Now, when I let the air back in, shaving cream is so weak that it not only shrinks back down, but it explodes too. So doing experiments like these with the vacuum chamber has taught me a lot. For example, before I got the vacuum chamber in the Action Lab subscription box, I never knew that air had weight. But once I did the marshmallow experiment like you saw in part 1, remember how when I let the air back in, the marshmallow got crushed down? Well, the only thing that got added was the air. So that was the only thing that could have crushed it. And that meant that air actually did have weight. The other cool thing about science experiments like these is that it makes me ask a lot more questions that I can't answer. Such as, why did the balloon get sucked straight up and then fell down when I let the air back in? Thank you for watching part 2 of the basics of a vacuum chamber. If you're interested in getting your own Action Lab subscription box, I'll leave a link in the description for the website. And also I have 2 shout outs to make. One to the Action Lab, of course, for teaching me so much with the vacuum chamber. I also want to shout out to the people over at Periodically Inspired. After I wore this shirt in part 1, they sent me this other one. It says, I eat tacos periodically. Tacos is spelled tantalum, carbon, oxygen, and sulfur. And down at the bottom, there's a taco atom. So this shirt was really cool, and I wore it for part 2. Before I end this video, I'm going to remind you to share it and subscribe. And if you don't know already, SciMastory stands for Science, Math, and History. Tell me in the comments, what should I SciMastory next? So, I know that second part might have been really confusing, but I'll explain it right now. So, the small space in the container, or space, remember how in part 1 the vacuum chamber expanded because of the
marshmallow? Yeah.
Vacuum chamber. Oh, you're you're recording?
Yeah.
Pump it. Whoa, that was so easy.
Oh, jeez.
Did you have it recording?
It's recording too.